Howdy and welcome to my video on simplifying and solving rationals. In this video, I will be doing exactly that. I will be simplifying and solving rationals. These problems have been taken from the Virtual Math Learning Center, and a link to those problems will be put in the description. Alright, so question 1, we're going to simplify the following. Whenever we divide by a fraction, right, we're just multiplying it by the reciprocal. So I'm going to rewrite this as this real quick. So the first fraction stays the same. And the second fraction gets flipped. X squared minus 2x minus 8. Okay. From here, we are going to factor. So if we take our first polynomial, we have x squared minus 3x minus 10. We need two numbers, multiply up to negative 10, add up to negative 3. That's negative 5 and negative 2. We can rewrite as x squared minus 2x minus 5x minus 10. Take out an x on the left side, we get x minus 2. Take out positive 5 from the right side, we get x minus... Wait, hold up. This should be positive 2. Positive 2, that's positive. If you take out a minus 5, we get a positive 2. Okay. Common factor, take it out. And we add the rest. So that's our numerator. Our denominator, same process. So we have 2x squared minus 9x minus 5. We're looking for two numbers that multiply up to negative 10 and add up to negative 9. This is negative 10, positive 1. We can rewrite as 2x squared. What do I want to do? Let's do plus x, sorry. Minus 10x minus 5. We can take out an x on the left side. We're left with 2x plus 1. You can take out a negative 5 on the right side. We're left with 2x plus 1. The common factor is 2x plus 1. And we can add up the rest. And that is our next that's our next polynomial, right? Now we move on to, where is it? Okay. Our third polynomial, which is the next numerator. 2x squared minus 9x plus 4. We're looking for two numbers that multiply to positive 8 and add up to negative 9. That would be negative 8, negative 1. We get 2x squared minus x minus 8x plus 4. When we take out an x from the left side, we're left with 2x minus 1. And take out negative 4 from the right side, we get 2x minus 1 remaining. And now, 2x minus 1 is our common factor. 2x minus 1. And then we add up the rest, x minus 4. Okay. And now, we can do our last polynomial, which is this one. X squared minus 2x minus 8. I'm blanking. Okay, we need two numbers to add up to negative 8. Multiply up to negative 8 and add to negative 2. These numbers are negative 4, positive 2. So we can rewrite this as x squared plus 2x minus 4x minus 8. We can take out an x from the left side, and we're left with x plus 2. We can take out a negative 4 from the right side, and we're left with x plus 2. We take out the common factor, and we add up the rest. Okay. So we can rewrite this product as x plus 2 times x minus 5 over 2x plus 1 x minus 5. And the other fraction we have 2x minus 1 x minus 4. And on the bottom, x plus 2 x minus 4. Okay. Now we can cancel out terms from top and bottom. Okay. So, did I use red? Oh, I did. Let's use brown. Okay. The x minus 5, we can cancel top and bottom. X minus 4, we can cancel top and bottom. X plus 2, we can cancel from top and bottom. And we are left with just 2x minus 1 over 2x plus 1. And that is your answer. All right, for number 2, same thing again, we're going to simplify. This time, though, we're subtracting. So we need to make sure that we have the same units on bottom and top. So first, we're going to factor those denominators and see what we get. So for the first denominator, we have x squared minus 4x plus 4. I'm looking for two numbers add up to 4, multiply up to 4, add up to negative 4. That would be negative 2, negative 2. So we rewrite this as x squared minus 2x plus 4. We can now rewrite, not rewrite. We can take out an x from the left. We're left with x minus 2. We can take out a 2, minus 2 from the left, the right, sorry. And we have x minus 2 remaining. Common factor, take it out. And now, add up the rest. And same factor, so you have x minus 2 squared. Okay. For the denominator, the other one that is, x squared minus 4, this is just difference of squares, so you get x minus 2, x plus 2. So you can rewrite this difference as x plus 1, x minus 2, x minus 2, okay, minus x minus 3, x minus 2, x plus 2. If we look at our left fraction here, we're missing an x plus 2. And if we look at our right fraction here, we're missing x plus 2. Sorry, the left fraction is missing x plus 2, the right fraction is missing x minus 2. So we can rewrite this as x plus 1. So I get x plus 2, right? And here we get x minus 2 squared, x plus 2. On the right, we have x minus 3 times x minus 2 over, so x minus 2, and there's another one, right? So squared, x plus 2. And now that we have the same denominators, we can just combine them together. So we have x plus 1 times x plus 2 minus x minus 3, x minus 2 over x minus 2 squared, x plus 2. Okay. The top simplifies down, or we can do it the left side. So x squared plus 2x plus x plus 3, and we minus x squared minus 3x minus 2x plus 6. All of that. We can simplify out that right side, the left side of the denominator. That's x squared minus 4x plus 4 over x plus 2. Keep going. So x squared plus 3x plus 3. That should not be 3, that should be a 2, right? 2 minus x squared plus, so this is 5x, right? So this is minus 5x, so negative negative is plus 5x minus 6 all over, then we 4 at the bottom, we get x cubed negative 4x squared minus 8x let's see, plus 2x squared. Oh, I think I messed up the order. Refollow that real quick. Okay, so you have x cubed, right? And plus 2x squared. 2x squared minus 4x squared minus 8x plus 4x plus 8. Need to check that. So x cubed, 2x squared, negative 4x squared, negative 8x plus 4x plus 8. Okay. Now we can go combine. This goes away, that goes away. Combine these together and these together. So our top is 8x minus 4. And our bottom becomes, so we have x cubed by itself. If we combine these together, you get minus 2x squared. This gives us minus 4x. And we get a plus 8. And that will be our answer. Oh, actually, I should note that this top, right, it gives you, if you take out 4, get 2x minus 1 over the whole thing, right? And if I go back to the factored form, it was x minus 2 squared, x plus 2. I should have left it factored first and then expanded, but luckily this for me cannot be cancelled out. So this is my answer. I should have factored first, like I keep this alone, expand this, and then when I factor, I can see if there's anything to do to cancel, and then I can solve. Either way, we got the right answer. All right, number 3 is to simplify again. The easiest way to deal with this one is to actually multiply top and bottom by 3x squared. So you have 2 over x plus 1 over 3x squared over 4 minus x minus 1, right? We can cancel all these denominators by multiplying everything by 3x squared. So top, bottom, right? Because what you do on top, you need to do on bottom. So 3x squared over 1, 3x squared over 1 to make it clear, right? We get, let's see. So we get 6x squared over x, 3x, wait, hold on, over x, right? Plus 3x squared over 3x squared. And on the bottom, we get 12x squared over x minus 3x squared over 1, right? So this simplifies down to 6x plus 1 over 12x minus 3x squared. If we factor the denominator, you can see that there is nothing left to be done, right? So this is our final answer. Okay, number 4, we are multiply and simplify. So once again, we are going to factor everything. and then cancel out terms and multiply. So let's start with this one here. So I have t squared minus t minus 6. I'm looking for two numbers that multiply up to -6, add up to -1. That's -3, +2. You can rewrite this as t squared minus, plus 2t minus 3t minus 6. We can take out a t from the left, and we're left with t plus 2. We can take out -3 from the right, and we're also left with t plus 2. Take out the common factor, add up the rest, and that's our factored version. Next one is the denominator on the left side, and we get t squared plus 6t plus 9. I'm looking for two numbers that multiply to 9 but add up to 6. We get 3 and 3, both positive. And we can rewrite as t squared plus 3t plus 3t plus 9. Take out a t from the left, we have t plus 3 remaining. Take out a 3 from the right, we have a t plus 3 remaining. Take out the common factor, you get t plus 3, add the rest, t plus 3 again. Okay. Next factor is just a t plus 3, so we actually don't need to simplify that. So the next polynomial is actually t squared minus 4 that I will factor out. T squared minus 4 is difference of squares, so this is simply t minus 2, t plus 2. Okay. Now we can rewrite our product. So t plus 2, t minus 3 over t plus 3, t plus 3 on the left hand side. And then we have t is a plus 3, yeah, t plus 3 over t minus 2, t plus 2 down bottom. So when we start canceling, let's see, t plus 3 cancels out with t plus 3. This t plus 2 cancels out with t plus 2, and you're left with t minus 3 over t plus 3, t minus 2. We can't factor this out anymore, nor cancel anything, so we will just FOIL the bottom. T squared minus, plus 3t minus 2t minus 6. That gives us t minus 3 over t squared plus t minus 6. There you have it. That is your answer for number 4. Okay, so number 5, we are now solving by using formulas. So we're just supposed to solve this using a quadratic formula. And remember, we need our ax squared plus bx plus c equals 0, right? So in order to do that, we're going to subtract both sides by 4x minus 3. And we get 4x squared minus 4x plus 3 equals 0. This is our a. This is our b. And this is our c. Okay. So when we do our quadratic formula, right, it's negative b plus minus b squared minus 4ac over 2a. We would then get a positive 4, right, plus minus, what is it? B squared is 16 minus 4 times 3 over 2 times 4, okay? So that inside of the radical, we get 16 minus 48 over 2 times 4. Let me double check something. Yep. And then we get 4 plus minus square root of 32, I want to say. 32, okay. Negative 32 over 8. And this then gives us arrow, right? So from here, right, this is no solution, no real solution. Because they're the square root of a negative number. But in the Math Learning Center, they want to use complex numbers, so we will continue going. So we have 4 plus minus, that's root 16 times root negative 1 times root 2, right? All over 8. That is 4 plus minus 4i root 2 over 8. This gives you 1 plus minus I root 2 over 2, which is just, if you derive it out, you get 1 plus I root 2 over 2, and 1 plus, minus, sorry, I root 2 over 2. And these would be your imaginary solutions, okay? And that is question 5. Alright, question 6. We're looking to solve this by completing the square. Okay, so we have our 3x squared plus 2x minus 3 equals 0. So what I'm going to do is I'm going to move this minus 3 over. So I'm going to add 3 to both sides. You get 3x squared plus 2x equals 3. Okay. I'm going to take out the 3 by dividing everything by 3. So you have x squared plus 2/3 x equals 1. Now, for completing the square, right? I know that because I have a plus sign. Since I have a plus sign, I want something in the form of x plus something squared, right? And let's say, this is like a, right? Then I know that I will get x squared plus 2ax plus a squared, right? So the question is, what is a? 2ax equals 2/3 x. So 2a equals 2/3, and a equals 1/3. Now 1/3 squared, right? A squared is 1/9. So what I'm going to do is add 1/9 to the left side and do the same for the other side. I can now rewrite the left side as my perfect square, and my other side as one fraction. I can now take the square root of both sides. So x plus 1/3. And because I start with an exponent, right? This is plus minus square root 10 over 3. So x equals 1/3, negative 1/3, plus minus root 10 over 3. That is the solution. All right, so for question 6, 7, 8, okay. So we're going to solve this by any method we want because we don't specify. Now you look at this question, right? Right, solve, okay. You see that we have 4 terms, right? 1, 2, 3, 4, and the powers are 3, 2, 1, and this is x to the 0, right? Which is 3 times 1. This is power 0. So we have descending orders by 1, and we have 4 terms. This generally means I can solve by grouping, I'm going to try grouping everything together. Okay. So I'm going to have x cubed minus 3x squared minus x, and I'll move that 3 to the other side, so plus 3 equals 0. Also, in general, just having a 0 on one side helps, right? Having 0 on one side can help. Okay. Especially when trying grouping, I need to make sure I have 0 on the other side, so I can set each factor to 0. So now, let's look at the left side of the left side. And take out an x squared, and we get x minus 3. If I take out a negative 1, I get x minus 3. Okay. Common factor, take it out. And then add up the rest. I can factor this due to difference of squares. So x minus 3, x minus 1, x plus 1 equals 0. And we get x equals negative 1, x equals positive 1, and x equals 3. Actually, let me solve it out manually. So x plus 1 equals 0. This means x equals negative 1. X minus 1 equals 0. This means x equals 1. X minus 3 equals 0. That means x equals 3. So our solution set is x equals, I cannot curly brace, negative 1 comma 1 comma 3. Why is my comma different? 3. Okay. That is my answer. And now for number 9, we have another solving, and we can use any method we would like. So first off, I would like to have similar or the same denominator, right? So we have 7 over 2x plus 1 minus 8x minus 2x minus 1 equals, and we'll say negative 4 over 1, right? The common denominator, and we can just multiply them all, right? So common denominator is just 2x plus 1, 2x minus 1. So greatest common denominator, okay? Or not greatest, we'll do like least. I don't know what the word would be. But anyways, we want this to be our denominator. So our fraction on the right is missing a 2x minus 1, right? So 7, 2x minus 1, and we get 2x plus 1, 2x minus 1. Fraction on the right, we get 8x. We need a 2x plus 1 here. So we get a 2x minus 1 times 2x plus 1 on the bottom. And on the other side, we get a negative 4 times 2x plus 1, 2x minus 1 over 2x plus 1, 2x minus 1. Okay. Let me think for a second. Okay, so now we have this, right? We can see that all the numerators are all the denominators are the same, right? So 1, 2, 3, right? So actually, is there a faster way to this? Nah. Okay. So yeah, our denominators are the same. So we can just focus on the numerators, right? So we can just take only the numerators. So this one, this one, and this one. Because if all the denominators are the same, then all the numerators should equal each other, right? So we will get 7 times 2x minus 1 minus 8x 2x plus 1 equals negative 4 2x plus 1 2x minus 1. We can start expanding. We get 14x minus 7 minus 16x squared minus 8x equals negative 4 times, this is difference of squares, so 4x squared minus 1. Okay. In a moment, trying to think. Okay. So we can rewrite this as negative 16x squared. This is, and you think negative 16x squared, right? And we have these combined, and we get plus 6x, 11 minus 7. And this is equal to negative 16x squared plus 4. These cancel. And we have 6x minus 7 equals 4. 6x equals 11. X equals 11 over 6. They want me to check my solution, so this is going to be a little painful, but let's go ahead and do that. So 7 over 2 times 11 over 6 plus 1 minus 8 times 11 over 6. 2 times 11 over 6 minus 1. Okay. We get 7 over 22 6, and we do plus 6 over 6. Okay. Minus 88 over 6 over 22 over 6 minus 6 over 6. And for my sake, I'm going to write 42 over 6 over here. We get 42 over 6 over 28 over 6 minus 88 over 6 over, that's 16 over 6. Okay. If you multiply everything by 6, right? Every numerator, every denominator, you get 42 over 28 minus 88 over 16. Left side, that should be 6. Wait, we can divide by 14, right? So 3 halves minus 8, so 11 over 2. We get negative 8 over 2, which is negative 4, which is what this is. So this is indeed the correct solution. All right, and for question 10, we need to solve this equation. If we try to find 2 factors, okay, so we need 2 factors multiply to 10 and add up to 8. But if you look at our possible combinations, right, we don't have any that add up to 8. So we have to go back to good old quadratic formula. So our 1 here, right, this would be our A. Our 8 would be our B, and our 10 would be our C. So we have negative B plus minus square root of B squared minus 4AC over 2A. We get negative 8 plus minus square root of 64 minus 4 times 1 times 10, all over, what would that be? 2 times 1, so it's just 2, right? I'm going to write the 1 here. This is negative 8 plus minus square root of 64 minus 40 over 2. Negative 8 plus minus square root of 24 over 2. This is negative 8 plus minus, so square root 4, square root 6 over 2. Negative 8 plus minus 2 root 6 over 2, and you get negative 4, plus minus root 6. And that is our answer. And with that, that concludes my video for solving and simplifying rationals.